Welcome, everyone, to a new episode of Connected Data Unchained. Today, we have the pleasure of having Victor Lee, a renowned graph expert who has authored a number of blog posts as well as a book around graph analytics and how it's used in real-world applications. So welcome, Victor.
Thank you, Hamid. It's a pleasure to be here with you today.
So in today's episode, I thought we dive deep into how graph technology and graph algorithms are being used to address some of the key problems around supply chain. I would love to hear kind of your perspective as to why graph is one of the enablers of addressing the complexities of this space.
Sure, it would be a pleasure. This is one of the, say, easiest use cases for people to understand why graph is a fit, and then for people who decide to use it to actually start to see benefit. And that's, if you think about it, just the phrase supply chain. It's a chain, it's a set of links. You're describing a graph. When you draw it on paper, every visualization is a graph. So people get that. But you have to take a little bit further. Okay, but aren't there like existing tools that manage this? What are they doing? What is graph doing differently? So I like to take a moment to talk about that and what are the challenges that only something like TigerGraph is really suited to handle. Traditional tools are based under the hood. You have tabular data so there's a mismatch between how they're representing the data internally and how the user envisions it. You know, it's a graph, so you'd want to store it as a graph. The thing about graph databases is they actually follow links, explore links, and search across links much more efficiently. It can be 100 times faster than in a relational database. And also, what type of work you want to do. So that gets to some of the challenges. So the traditional ones tend to be very use case specific. You'll see products aimed at particular industries, like, you know, people who are in a certain segment of retail. They may have a custom product. It's nice, but it's not flexible. Once their needs change, then they have to see if they can get the vendor to add something. They tend to be, you know, point solutions where a graph is really an open-ended platform that can potentially satisfy all your different needs.
So, if I may, it's one thing to say that graph lends itself really well to the fact that data in a supply chain type of solution are all connected, and the fact that these connections could be multi-hop deep and so forth. But one of the things that I was hoping that you could also allude to is, having dealt with so many customers, can you give us an idea of the complexity of these supply chain customers that have basically opted to use graph as the only way to be able to tackle these problems, like size, kind of manufacture, basically the whole supply chain and the complexity around it?
So we have a lot of customers, particularly for supply chain, that either they have a large national presence or they really are global international companies. So not only may they have dozens, if not hundreds, or even thousands of products. You know, for example, somebody in making, you know, personal care products may literally have 1,000 products. Then you think about how many components, ingredients go into all those things. That's a multiplier. And there can be multiple stages. It's not just one level of manufacturing, it's multiple stages. Then those come from different, you want to be multi-sourced when possible. You don't want to rely on a single supplier. So that means there are multiple suppliers. You're crossing national boundaries. You have different assembly facilities. That's just the production. Then you get to distribution, and you have a similar network which is fanning out in breadth. So before, you were going really wide with lots of different suppliers, lots of different components and subcomponents coming down to make your products. And then it widens out again when you go into distribution. So it's huge. First of all, there are few systems that can even represent all of that, store it. Then you get to I need to actually work with that data. I need to see what's happening. I need to analyze it. And ideally, I'd like to perform optimizations or engineer my supply chain to be better, to avoid problems. And that's what I was getting to, the resilience of their supply chains that companies need today.
That's actually a really good point to make, which is it's not just the complexity of the entire supply chain and the magnitude of the problem when it comes to the sheer amount of data for the thousands of products, tens of thousands of components, the multitude of suppliers, even the inventory pipeline and inventory management, which is yet another aspect of it. But also, actually, even one more perspective on that is some of the regulatory compliance or issues with various materials and so forth that comes into play. But also, there are specific needs that this industry has. So maybe you could tell us a little bit about some of the key use cases that comes to mind when you think about supply chain solutions.
So I can give an example of one of our customers, Jaguar Land Rover. So automobile manufacturer. Everybody knows automobiles have many, I don't know, tens of thousands of components coming from multiple tiers of suppliers. But when we started working with them and to understand what their particular problems were, they pointed out things like this. So they have contracts with their suppliers with both minimum and maximum thresholds. So they they may have to pay a minimum, whether they use the component or not, they have to pay a minimum.
Mm-hmm.
There can be certain penalties if if Jaguar Land Rover, changes things, if they go too high or too low. So they want to sit within an ideal range, right? There are regulatory requirements. They have certain, government regulations they have to follow. There are labor regulations they have to follow, union contracts. So, and they're also trying to say, how responsive is their supply chain to the demand? There's a long lead time to make an automobile. So even if they have a good prediction of what they think the demand will be 3 to 6 months from now, can they actually steer the production towards that? That was one of their challenges. The current system they had, it was so clunky to try to run a simulation that they effectively could not find out the answers in time. They needed a system where they could have the basic inventory and production flow available, the demand preference, the financial aspects of the contracts, run a simulation and get the answer quickly enough that they could actually do something about it. It used to take them weeks to try one scenario. TigerGraph was able to lower that to less than 1 hour.
Wow, that is incredible. That's absolutely incredible. Part of the complexity of the supply chain solution is the fact that manufacturers produce products in batches, and sometimes the configuration of the same product may vary from one batch to another. I don't know if you've come across this or not, but can you tell me about the use case where there has to be going back to your car analogy, car manufacturing analogy, was there a use case where there was a recall and they needed to, can you describe some of the complexities associated with having multiple batches with potentially different components and different suppliers that comes to mind?
Sure. So the graph makes it quite easy and straightforward to trace where has a batch gone, because you're basically just watching the flow go downstream. A batch entered the system here. You can see which products, which larger components till it finally makes it into a product. And then again, it flows through the supply chain into different distribution centers, different retail outlets. So it's fairly easy to track. And then you get to the question of, what can I do about it? If you, in some cases, it's pretty straightforward. There was a one-time bad batch. It was a one-off. It's not happening again. I just have to maybe replace the end product for some customers. So that brings up an interesting question. If you actually have to make replacements, you do repairs on automobiles, substitute in a good component, you've got to get supply of that, right? And you've got to get it out there. So yeah, you can see who are my alternate suppliers, what does it take to produce that? And then you do some upstream analysis of if I need more of this component, what is it going to take? What is that? Is it going to take away from other things? So you may actually, based on, maybe government regulations, you may have little leeway, but at least you can do the analysis and warn all your stakeholders about what is going to happen. Best case, you have some flexibility and some choices about how you handle the situation. But both that combination of downstream analysis and upstream analysis puts that information in front of you so you can make the right decisions.
That's actually also a very interesting point. If you think about graph algorithms and the capabilities that they bring as part of building a solution for supply chain, when you think about an alternate component or an optimization of a batch in terms of cost, time to produce, complexity, quality, how can graph help you quickly look at alternatives and more easily make a decision there? Can you think about previous capabilities that come to mind basically in this space?
Yes. So because we are talking about flows and paths, things like shortest path algorithm can be a very simple tool. And when I say shortest, there can be weights to the different stages. So it doesn't just mean this is 3 steps and 4 steps. You can actually put a cost to 2 different links. So you can see which is the, most, and those costs could be dollars, it could be time, it can be whatever makes sense to you. So whatever you want to optimize, you can use as a shortest path algorithm. If you want to look at the whole system, then you can do a maximum flow analysis of given these inputs, how much output can I get in this amount of time? If you're trying to pinpoint where are the areas where I may be at most risk because there's the most dependency. If something goes wrong there, it as some people have called it, has a huge blast region. You can run a centrality algorithm.
Interesting.
Centrality algorithms are very graphy. They look at all the surrounding links and usually not just one layer, but multiple layers. So it gets a cumulative analysis of, again, that analogy of the blast radius. If something happens here, how much impact does it have?
That makes sense. Actually, it's a really good point as well. Now, one thing I heard some customers talk about was this concept of supply chain fraud. Can you shed some light as to what does that mean? And again, how does Graph help with this aspect?
Okay. There are multiple types of fraud. So there are people, in the case of supply chain, you have people who maybe are selling faulty components, right? The quality is not there. Somehow they got on the market, but it's not a good quality component. There are things that can happen in shipping where what you ordered doesn't actually arrive. And then there's various types of payment fraud. So there's slightly different variations of the analysis you can do. So one, there is sort of a remediation. If the problem has already occurred, what can I do about it? And then there's detection, where you try to predict if that person is a fraudster. And of course, that's the best case. We have analogous efforts in our financial fraud applications. So we're able to transfer some of that knowledge. But again, to try to, maybe focus on one example. What you hear about a lot in the news, unfortunately, I think I've heard it in the airline industry with certain suppliers making really low quality components. And so the manufacturers have to figure out, where have those planes ended up? Who did we sell those planes to? Which planes have those particular components? So that downstream analysis is very important. And then again, that's where then they look for the alternate supplier, the cheapest way to get that new replacement component produced and then sent to the district. Airlines have very specific places where they do maintenance. You have to actually get it to that particular facility somewhere in the world. And I've also, seen how that sometimes can be a problem. And so being able to have a digital twin of your operations can really save a lot of effort in trying to figure out how you are going to manage one of these situations.
That's awesome. If we were to kind of shift gears a little bit, when I think about all of the excitement around generative AI, the concept of co-pilots and such, how do you see these technologies are going to help with supply chain solutions, specifically with the recent announcement from TigerGraph around the Copilot product that is coming up in this year? Can you shed some light as to what do you think are some of the examples of using such technology to make it that much easier for supply chain companies to leverage it to improve their operations?
Sure. And this is a really exciting development. TigerGraph is doing a great job with taking the generative AI capability and merging that with the graph analytics capability. If you think about in supply chain, we have domains where people use very specific terminology, and it may vary from one industry to another, or and this is a case where generative AI can help, where the user doesn't have to know too much about the details of the particular system they're using. They can use the language that they're used to using. Ask the question, and the system will translate that. It also, again, they don't have to understand exactly how we model the data. They just have to ask what is their need. You pose the problem. I've heard that there may be a cheaper new method of producing this component. Tell me if that's something that would work for my company. And then the system can, look at the available data and analyses and run that analysis and give them an answer.
Nice. What about what if type of scenarios? Can you think of how we could use that as part of this capability?
Yeah. So, one thing, this is an area where in general, this generative AI has been great for democratizing technology, as we say. It means that the amount of training and sort of expertise that the user needs, it can be lowered. So it means that you're closing the gap between the sort of business people who have the need and the technologists, engineers who know how to run the system. And so you're closing that gap, and then you're also allowed to iterate, because a lot of questions are not just one-time questions.
Yeah.
You work through a problem. So, and people who have played with these, tools like ChatGPT, you talk with it, you have a conversation to kind of refine your question till you get what you want. You can do the same thing here, but in a business setting where you are refining the results of the questions. So the big challenging problems are not one-offs, right?
Mhm.
Challenging problems you have to massage. And generative AI is going to help that. It's going to make the interface, again, shorten the distance between the stakeholders and the technology, so they can iterate more effectively and ultimately get better results. Again, I know you want to try to make a specific example, so maybe let's flip to the consumer products.
Mhm.
We're trying to have an option of what sort of fake milk, was almond milk or oat milk or
Mhm.
milk to actually have on the retail shelves. They the grocery store chain can get any of these, and they're trying to decide, which they should sell. And it depends on how you look at the problem. Are you trying to, just maximize revenue in the short term? Are you trying to build a market? Are you trying to serve the needs of your particular customers? Or are you trying to follow national trends? You can get different answers to different questions, and you can try all these things with the system and then see, if I want to do that, is the supply available? Yeah, so let's look at another case where you're trying to find where in your supply chain you're most at risk. For example, which suppliers, either the likelihood that they will cause a problem, or that if there's a disruption, that which one would have the most effect. I talked about centrality algorithms before. PageRank is actually a centrality algorithm. A lot of people know it from web search. It was the first graph algorithm that was really good at saying which should be the top result that you see for your search if you're doing a web search. And the reason why is it says that's the most influential, in the sense that the most other web pages think that's an important web page. And so you can actually put that in a different domain here. It says other parts of your supply chain rely upon this. So an algorithm like PageRank could first identify those. Then you evaluate alternatives. So in this case, what you're actually trying to smooth things out so that you don't have these hot spots. And so you can try another scenario. What if I move this over here? Does that smooth things out so I don't have these hot spots anymore?
Got it. Awesome. Well, Victor, we're at time, so I really want to thank you for taking time to talk to us about how graph technologies and AI are actually being used to address some of the most complex problems in supply chain solutions. Thank you so much for your time. Really appreciate it.
You're welcome. Thanks.
Awesome. Thank you. Take care.